Neutral bars are essential components in electrical systems, serving as the connection point for neutral conductors. Determining the precise code requirements for their installation and location necessitates a thorough understanding of the applicable electrical codes and standards. The National Electrical Code, or NEC, is the primary standard for electrical installations in the United States, and it contains numerous articles and sections that pertain to grounding and bonding, which are directly related to neutral bar requirements. Firstly, it's important to consult Article 250 of the NEC, which covers grounding and bonding. This article provides detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding of electrical equipment. Secondly, within Article 250, specific sections address the sizing and installation of grounding and bonding conductors, as well as the connection of these conductors to grounding electrodes. These sections are crucial for understanding how neutral bars are integrated into the overall grounding system. Thirdly, the location of the neutral bar itself is typically dictated by the type of electrical service and the equipment in which it is installed. In a service panel, the neutral bar is usually located near the grounding electrode conductor connection, providing a direct path to ground. Fourthly, in separately derived systems, such as those supplied by generators or transformers, the neutral bar must be bonded to the equipment grounding conductor at the source of the separately derived system. This ensures that a low impedance ground fault path is established. Fifthly, understanding the difference between grounded conductors, or neutrals, and equipment grounding conductors is critical. Grounded conductors carry current under normal operating conditions, while equipment grounding conductors provide a path for fault current to return to the source. Sixthly, the NEC requires that grounded conductors be insulated, while equipment grounding conductors can be bare or insulated. Seventhly, the connection of grounded conductors to the neutral bar must be made in a way that ensures a reliable electrical connection. Eighthly, the neutral bar must be securely mounted within the electrical enclosure and properly identified. Ninthly, it is also important to consult local amendments to the NEC, as these amendments may impose additional requirements for neutral bar installations. Tenthly, local electrical inspectors are valuable resources for interpreting and applying the NEC. When searching for specific code requirements, it's helpful to use keywords such as neutral bar, grounding, bonding, service entrance, separately derived system, and equipment grounding conductor. Online resources such as the NEC Handbook and various electrical code forums can also provide valuable information. Remember that electrical codes are subject to change, so it's essential to consult the latest edition of the NEC and any applicable local amendments. In addition to the NEC, other standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, may provide guidance on grounding and bonding practices. The IEE 142, Recommended Practice for Grounding of Industrial and Commercial Power Systems, is a widely recognized resource for designing and implementing effective grounding systems. This standard covers a range of topics, including grounding electrode systems, equipment grounding conductors, and bonding techniques. It also provides guidance on mitigating ground loops and other grounding-related problems. When working with electrical systems, safety is paramount. Always de-energize circuits before working on them and follow proper lockout/tagout procedures. If you are not qualified to perform electrical work, consult a licensed electrician. Furthermore, understanding the specific requirements for neutral bars in different types of electrical systems requires careful attention to detail. In residential electrical systems, the neutral bar is typically located in the main service panel where it is connected to the grounding electrode conductor. The grounding electrode conductor connects the neutral bar to a grounding electrode, such as a ground rod or a water pipe. In commercial and industrial electrical systems, the neutral bar may be located in a main distribution panel, a sub-panel, or other electrical equipment. The size and configuration of the neutral bar will depend on the size of the electrical system and the number of circuits it serves. Separately derived systems, such as those supplied by generators or transformers, require special consideration. In these systems, the neutral bar must be bonded to the equipment grounding conductor at the source of the separately derived system. This bonding connection ensures that a lower impedance ground fault path is established. The NEC provides specific requirements for bonding separately derived systems in Article 250.30. Another important consideration is the proper identification of neutral conductors. The NEC requires that neutral conductors be identified by a white or grey color. This color coding helps to prevent accidental miswiring, which can create a safety hazard. The neutral bar itself should also be clearly labeled to indicate its function. When installing or modifying electrical systems, it is essential to follow all applicable code requirements and best practices. Failure to do so can result in electrical shock, fire, or other hazards. Consulting with a qualified electrician or electrical engineer is always a good idea, especially when dealing with complex electrical systems. In addition to the NEC and other standards, various training resources are available to help electricians and other electrical professionals stay up to date on the latest code requirements and best practices. These resources include online courses, seminars, and workshops. Continuing education is essential for maintaining competency in the electrical field. The proper installation and maintenance of neutral bars are critical for ensuring the safety and reliability of electrical systems. By following all applicable code requirements and best practices, you can help to prevent electrical hazards and ensure that your electrical system operates safely and efficiently. Furthermore, when examining neutral bars, it's crucial to inspect for signs of corrosion, damage, or loose connections. Corrosion can increase resistance and reduce the effectiveness of the grounding path. Damaged or loose connections can also create a fire hazard. Regularly inspect neutral bars and tighten any loose connections. Replace any components that show signs of corrosion or damage. Understanding the role of neutral bars in mitigating electrical noise is also important. Electrical noise can interfere with the operation of sensitive electronic equipment. A properly grounded neutral bar can help to reduce electrical noise by providing a lower impedance path for noise currents to return to the source. The NEC also addresses the use of surge protective devices, or SPDs, to protect electrical equipment from voltage surges. SPD are typically connected to the neutral bar and the equipment grounding conductor. They divert surge current to ground, protecting sensitive electronic equipment from damage. Furthermore, the NEC provides requirements for the installation of arc fault circuit interrupters, or FSIs, in residential electrical systems. FSIs are designed to detect arc faults, which are a common cause of electrical fires. FSIs trip the circuit breaker when an arc fault is detected, preventing a fire from starting. The location of the neutral bar within an electrical panel can also impact the performance of FSIs. For example, if the neutral bar is located too far from the FSI, it may not be able to detect arc faults effectively. When designing an electrical system, it's important to consider the location of the neutral bar and its impact on the performance of other electrical components. Moreover, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. This listing ensures that the equipment meets certain safety standards and is suitable for its intended use. When selecting electrical equipment, make sure that it is properly listed and labeled. The NEC also provides requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC classifies hazardous locations into different classes and divisions depending on the type and concentration of the hazardous material. Electrical equipment installed in hazardous locations must be specially designed to prevent ignition of the hazardous material. The installation of neutral bars in hazardous locations must comply with the specific requirements for that location. Also, the NEC addresses the use of flexible cords and cables for connecting electrical equipment. Flexible cords and cables are often used to connect portable equipment or equipment that requires movement. The NEC provides requirements for the type of flexible cord or cable that can be used in different applications. The neutral conductor in a flexible cord or cable must be properly identified and connected to the neutral bar. Additionally, the NEC requires that electrical systems be inspected and tested periodically to ensure that they are operating safely and correctly. These inspections and tests can help to identify potential problems before they become serious hazards. The frequency of inspections and tests will depend on the type of electrical system and the environment in which it is located. Understanding the requirements for neutral bars and specific types of electrical equipment, such as motors, transformers, and generators, is also important. The NEC provides specific requirements for the grounding and bonding of these types of equipment. These requirements are designed to ensure that the equipment is properly grounded and that fault currents are safely diverted to ground. The NEC also addresses the use of high-impedance grounding systems. High-impedance grounding systems are used in some industrial applications to limit the amount of fault current that flows during a ground fault. These systems use a resistor or other impedance device to limit the fault current. High-impedance grounding systems can help to reduce the risk of equipment damage and electrical shock. In summary, locating the specific code related to neutral bars requires a multifaceted approach. Firstly, begin with Article 250 of the NEC focusing on grounding and bonding requirements. Secondly, identify the type of electrical system involved: residential, commercial, industrial, or separately derived. Thirdly, consider any local amendments to the NEC that may apply. Fourthly, consult with qualified electricians or electrical inspectors for clarification and guidance. Fifthly, utilize online resources and electrical code forums to research specific code sections. Sixthly, pay attention to the specific application of the neutral bar, such as in service panels, subpanels, or equipment grounding systems. Seventhly, ensure proper identification and labeling of neutral conductors and the neutral bar itself. Eighthly, regularly inspect neutral bars for corrosion, damage, or loose connections. Ninthly, understand the role of neutral bars in mitigating electrical noise and protecting against voltage surges. Tenthly, stay up to date on the latest edition of the NEC and any applicable standards. By following these steps, you can effectively locate and interpret the code requirements for neutral bars, ensuring the safety and reliability of electrical systems.